break time now. As I have told you many times that you see in the real class we take a physical break after about an hour. Here already all your video lectures are in pieces of 15 minutes. So after every 15 minutes you can take a break, and you should generally if you can then take a 1 minute, 2 minute break, refresh your mind, take a sip of something, right? But this is the mental break. This is a very modern break, right about you guys and me, and right about the current world, the COVID-19, the online system. You see, there is this teacher and there is this student. The quiz is there. And after the quiz is finished, the teacher receives an email from one student that, "Doctor, I am sorry, I could not do the quiz because internet is not working in my village." Break is over. The student is sending an email to me that, "Doctor, I am sorry, I could not do the quiz because internet is not working in my village." So we were just telling you the steps in shell molding once again. So now, right, the box is inverted so that the sand and resin fall onto the hot pattern, causing a layer of the mixture to partially cure on the surface to form a hard shell. So a shell is now made, right? The box is rotated. Now the box is repositioned so the loose particles drop away, right? So now it is again rotated, and whatever sand glued to it is there, the shell is there, the rest of the sand is here. And then the sand shell is heated in an oven for several minutes to complete the curing. So the shell that was made in the previous step, you take that and you heat it in an oven. Of course, everything, the temperature, the time and so on are pre-designed by people who are very knowledgeable in the type of sand they are using, in the type of binder that you are using, in the type of chemical agent and so on. So what temperature will be there in the oven for how much time, 2 minutes, 3 minutes, it is all pre-designed, right? So now the shell mold is stripped from the pattern. The pattern is a metal, remember, right? So now either by heat or that there was already some parting agent here. Now this shell is removed. So this is the pattern. This is the mold. This was the pattern. This can be used again and again to make the shell. And now, right, the two halves. So this is one half, this is the other half. So now this is the total flask, and the two shells are there and they are clamped together, right, and so forth. So the two halves of the shell mold are assembled, supported by sand or metal shot in a box. Outside it there is some sand or some metal shot. Metal shot means a small pieces of the metal to support it, because you have to support it now, right? You have to support it, and the pouring is accomplished. So now you start pouring it, right? So this will be a little more costly than normal sand casting, because the type of sand that you are using for the mold here is much finer. That is why the surface finish and the dimensions are better. And then you need those patterns, which are metal patterns, to be heated, and then you need some oven curing afterwards, and then you need to pack this general sand around it. So it is a little more cost, but this part can also be sand. This is also sand mold, but the real sand mold is only this shell. And because in this shell the exact dimensions and the surface finish is very good, therefore the final casting can maybe directly used, and you don't need the sprue and so on here. The sprue is, the pouring basin is only here, only this much is to be broken, right? So it is more costly, but still lower cost than some other types of casting, and a near final finish is already there. So now, right, the finished casting with the sprue removed and so on. Advantages and disadvantages, I tell you that if you think you already know the advantages, but we will just to save time, quickly go through it. A smoother cavity surface permits easier flow of molten metal and better surface finish. Easier flow and better surface finish. Good dimensional accuracy. Mold collapsibility, breaking of the mold, because it is only a thin shell rather than breaking the whole core and so on. And can be mechanized for mass production. This is major, that these steps, step 1, step 2, step 3, can be done automatically, mechanized. Disadvantages: more expensive, metal pattern is there and the whole process is more expensive, and it is difficult to justify for small quantities, of course, because the cost now with the metal pattern, with the heating arrangement, with the oven arrangement and so on, with the mold, shell mold in 2 pieces and joining them together. So the cost is extra. Therefore, unless you have many pieces to make, if you have 5-10 pieces to make, then just do it by normal sand casting. But if you have a large number of pieces, then all this additional cost per piece, because you see, the extra cost is divided into 100 pieces. The extra cost is divided into 500 pieces. So the extra cost per piece is almost nothing, right? So this is there, the advantages and the disadvantage. Another method, plaster mold casting. Plaster mold casting. So again, don't read, just tell me where you have heard the word plaster. Where you have heard the word plaster, either you have used it yourself or you have heard it somewhere. Yes, those of you who are saying 2 different things. One is that if, na'udzubillah, anybody has a bone fracture, and you go to the hospital, to the surgery department, to the orthopedics department, and then they put a cast around you. So that material which they put around you after setting your bone is called plaster, right? So that is a major place where plaster is used. And if you play with girls and so on, I don't know if girls do it today, if they make the dolls at their own home, just don't go and buy a doll. If they make dolls at home, then there is this method that people are interested, they do it. They plaster is the material, and the doll they want, they have a very thin shell, right? Just like the shell mold. They have a thin shell, plastic shell of the doll. And then they pour the plaster, they prepare the plaster at home, they pour the plaster inside, and after it cools down, then they remove the outer plastic and the doll is there with the whole shape. Now you can do your own painting and patterns and so on. So people who are interested in doll making and so on, so the plaster is there, right? And so forth. Okay. So this is the plaster. Plaster mold is similar to sand casting, except that the mold is made of plaster of Paris. It is a special type of plaster which is called plaster of Paris. Gypsum, calcium sulfate with water, right, is used to make plaster of Paris. It is not just gypsum. Gypsum is one material which is used together with some others to make what is called the plaster of Paris. In mold making, the plaster and water mixture is poured over plastic or metal pattern and allowed to set. Wood patterns are not generally used due to extended contact with water, right? Because you see, in the plaster we will use much more water than in any sand casting and so on. So the pattern will be in contact until the mold completely dries out. So if wood is there and it is contact in water repeatedly, the wood pattern will be wasted. Therefore, plastic pattern or metal pattern. Of course, the metal pattern will have to be good so that it does not corrode easily. The plaster mixture readily flows around the pattern, capturing its fine details and good surface finish. Right? This plaster of Paris is a very fine powder. So it is even finer, say, than the fine sand used in shell mold casting. So the surface finish and the final dimensions will be very nice. Again, the advantages and disadvantages: good accuracy, good surface finish, capability to make thin cross sections. Advantages. Disadvantages: mold must be baked to remove the moisture, otherwise the moisture can cause major problems in the casting. The mold strength is lost if over baked. So the baking has to be very careful so that the moisture is removed, but you don't over bake, otherwise the strength is lost. And plaster molds cannot stand high temperatures. So it is limited to alloys that have lower melting points, right? Because the plaster mold is there. If the metal that you pour is of a higher temperature, then the plaster is gone. So very good surface finish, very good final size, but right, only low melting temperature alloys can be used. But if they can be used, then it is a very good method. Applications of plaster mold: metal molds for plastic and rubber molding. Right, the molds that you use to make rubber and plastic molds. Pump and turbine impellers, this are major. Other parts of relatively intricate or complex geometry. And this of course can be used for lower melting point alloys such as aluminum alloys, magnesium alloys, and some copper base alloys only. But if these are the things, then even complicated things like pump and turbine impellers and so on, impellers, fans, not the whole pump and turbine, impellers and so on, and other intricate geometry, right? So this is the third method. The first, the largest, is sand casting. The second was shell mold casting, and the third was plaster mold casting. Ceramic mold, right? Sorry for my typing mistake, right? This is E, not ceramic. Ceramic, E, my typing mistake, sorry for that. You see, everything is human error, and later on hopefully I will remove it, but for your class now this error is there. It is ceramic. Once again, you know, right, from your material science that ceramics are a type of material. Sand is itself a ceramic. Sand is itself a ceramic. The plaster of Paris may itself be a ceramic. But here we will use ceramics of higher strength so that they are higher temperature resistant. So this is similar to plaster mold casting, except that the mold is made of a refractory ceramic. Refractory, remember, high temperature resistant, that can withstand higher temperatures, right? So it is a type of, say, improvement on the plaster mold casting. That in plaster mold, a lot of advantages are there, but the major disadvantage was that plaster will melt or break and will not be stable at higher temperatures. So you could use plaster mold only for metals, alloys that are low temperature. Now you use material which is refractory ceramic. But of course, you will have to have very fine powder of this ceramic. You will have to have very fine powder of this ceramic. The rest of the process will be similar to plaster mold casting. So you don't need to define and describe these steps. Can be used to cast steels, cast irons, and other high temperature alloys. Applications similar to those of plaster mold casting, except that the metals in the previous one, for example, if we were making impellers for turbines and so on, but if we are using aluminum impeller, this time you can use steel impellers. Advantages of good accuracy and finish are of course there, and the other added advantage is that you can use alloys and metals which are very high temperature alloys, because the mold is now made of ceramic, and ceramic is much higher temperature, right? So this is a major advantage. And here the steps, there is a transfer bowl, the ceramic slurry, right? Ceramic powder mixed with the liquid to make it flow, ceramic slurry. And then there is the pattern, you pour it in the pattern and the flask is there, right? And then you can remove the things, stripping the green mold, you can remove, right? So only this part is remaining. And this part is then baked with a torch and so on, so that the extra parts are burnt off and it becomes a little stronger through baking also.